So in this lecture, I'm taking 4 examples and we'll see how to find limit for those functions. The first one, you have tangent x over x, x approaches 0. So this one you have seen in my previous video that I can use as a formula tangent x over x, which is 1, or I can just put it this function in the calculator and trace on the left side of 0 and right side of 0 using the concept of left hand limit and right hand limit. Both the cases it will be 1. But I want to see other way. Say that we know some formula that limit x approaches 0, sin x over x is 1. So let us apply that one. You know your tangent x is sin x over cosine x. So we'll see how I write my simplification. So first I'm approaching like tangent x is sin x over cosine x. And in the next step I do some more simplification. So you can see I'm writing sin x over x and another one is 1 over cosine x. I keep like this. Now if you consider two different problems in here, the first one when x approaches 0 is 1. And then you can just replace x by 0 here. So you get 1 over cosine 0, and you know cosine 0 is 1. So finally you get your answer 1. So this is another approach I show you. Now I'm going to the second example. In this case I have x minus 2 within the absolute value sign. So I need to understand the definition of absolute value. Let me explain that one, what happens on x minus 2. This is a plain definition. You can see when I say x minus 2 greater than 0, so x minus 2, this term is positive. Inside the absolute value sign, if you have a positive number, you can ignore the absolute value sign. So they're same as this. But what happens when it is less than 0? You can easily understand. Now you say that x minus 2 is less than 0. So less than 0 meaning is x minus 2 is a negative term. So if x minus 2 is a negative term, how do you make it positive? Just multiply x minus 2 by a negative sign. That's it. So then it will be actually x minus 2 with a negative sign. So I'll be using this concept to deal with this problem. So let us work on right hand side. So let me say x approaches to 2 plus. That means my x is greater than 2. So then when x is greater than 2, so x minus 2 is a positive number, so I can remove the absolute value sign. Now you can see this factor will cancel out here and here. And then if you plug the limit x equals 2, so 2 plus 2 is 4. So we got our right hand limit is 4. Let us look at left hand limit. I'm going to the left hand limit now. I say now my x approaches to 2 minus. So 2 minus meaning is you can assume your x like 1.9999, something like that. So that means our x is less than 2. So then x minus 2 is a negative number inside. So when I want to put it outside without my absolute value sign, I must put a negative to make it positive. Now you can see that this one cancelled out. Now if you plug x equals 2, you get a 4 with a negative sign. So negative 4. So now you can see your right hand limit is positive 4, but the left hand limit is negative 4. So then this limit does not exist at 2. You have a jump. So our final conclusion is limit does not exist. You can just write DNE. All right, but I want to show you this one also in the graphing calculator, how you deal with it. So let me type the function in my graphing calculator. Numerator is x squared minus 4 divided by, now I go to math, and under numerics, first one is your absolute value, then you type x minus 2. Now graph your function. Let me extend my window. I'm going to zoom 6 for my standard window. So you can see this is just coming in the calculator. Many calculators will not show this, but you can see that you have a jump in here. You can just go to trace, look at 2.0001. Okay, so right hand limit. My answer is 4. Now I'm going to left side, 1.9999, which is left side of 2, and then enter. That gives you -4. So that exactly we have found. I forgot to mention, before you go to the calculation, if you plug x equals 2, you see 4 minus 4 over 2 minus 2, so you get 0 over 0. That's why we did some work to figure out how we can get the limit close to 2. Same thing happens in example 3. If you replace h by 0 here, you get 1 over a minus 1 over a, which is 0. And then another 0 here, 0 over 0. That means we can do something on this. So the numerator, we are just working with the concept of adding, subtracting fractions. In elementary school or high school, you have seen it. So what I'm doing, a plus h times a is in my denominator, which is the common denominator. Now a times 1 is here, a plus h times 1 is on this side with a negative sign. Now after simplification, you get the following step. Is it not difficult to see? For example, when you open the parenthesis in here, a will cancel out, so h will come out with a negative sign, and the rest we just keep it. Now this h, will cancel out with just the concept of fraction division, so they'll cancel out in here, this h. Now when you plug h equals 0 on these, you get -1 over a times a plus 0, which is a squared. So you're done. I'll look at example number 4 now. Let us plug x equals 5 in the numerator and denominator and see what happens. So we have 5 squared minus 15 divided by 25, or 5 squared minus 5 minus 20. So we can see our denominator is 0, but numerator is 10. So it's not 0 over 0 form. Then we say that limit does not exist. And you don't have to simplify this one. We are done.